Can you all hear me?
Yes, ma'am.
Okay, thank you so much. Uh, Welcome to week 3 of the problem solving sessions for this course. I am Shreya and I'll be discussing few of the sums and the concepts which were discussed during week 3 lectures. Before moving on, I would like to discuss one of the problems that I was stuck during the last week lecture. So first I would like to clear that up and then proceed with this week's content. Uh, if it is fine, I think it is already 10 minutes past 3, so we can start. Okay, shall I start?
Yes, ma'am.
Okay. So, how many of you were there during the last week? Were you there? Okay. Anyway, I'll just start with this. So, we had this problem where x was a continuous random variable given by this PDF, and we had to find the cumulative density function of y. So for this thing we can write now, so CDF of y, cumulative density function, is written of for y can be written as probability capital Y less than equal to small y. Is it okay? Now instead of capital Y, I can replace capital Y and write it as probability capital X square less than equal to small y. Now since this x square is less than equal to y, we can write this as probability minus root over y less than equal to x less than equal to root over y. Is it okay? Any doubt here? Hopefully not. Okay. So then the CDF we have written in terms of x. Now we have to find the probability that x lies within this range, and we are given the PDF of x. Then how can we write this? This can be written as integration. Since this is a continuous random variable, we can write this as integration over minus root over y to plus root y fx dx. Okay, so now we have minus root over y to root y. Fx was how much? Half e to the power minus mod x. So we can write this as half e to the power minus mod x dx. So we have written this down, minus root y to root y fx dx minus root y to root y half e expectation of minus mod x dx. Now this one is an even function. So when we have something like minus a to a, so this one we can, because if it is positive, then also it's half e to the power minus x, and if x is negative, then also this is half e to the power minus x, and these bounds are same. So integration of minus a to a fx dx becomes 2 integration of 0 to a fx dx when f is a even function. So using same concept, we can write this as 0 to root y half e to the power minus x dx into 2. Okay, so we are using this concept over here. Alright, so now this 2 and this 2 cancels out, so we can write it as 0 to root y. Now over when x is greater than 0, mod x is also x, so we can write this as e to the power minus x dx, which can be written as minus of e to the power minus x from bound 0 to root y. So this can be written as minus e to the power minus root y minus of, we substitute 0 over here, we'll get minus 1. E to the power 0 will be 1. So this is nothing but 1 minus e to the power minus root y. And what is the range of y? So here x was for all x belong to the entire real number. Y is x square, so y will always be positive. So the range of y will be 0 less than equal to y less than infinity. So this is the final answer. Option C. Is it okay? So for those of you who joined a little late, I will repeat. This was my question. We had a random variable and a PDF given. So y was the transformed variable which was x square. Now first we'll write the CDF of y, that is probability capital Y less than equal to y. Instead of capital Y, we'll write x square less than equal to y, and then we'll break it up and write it as minus root y less than equal to x less than equal to y. Now since we have expressed this is a probability in terms of x, so we need to integrate within these bounds the PDF of x. So then this was the PDF which we wrote. Now since this is an even function and we had minus a to a some integration of some even function, that can be written as twice in the positive range, 0 to a this thing. So using this we wrote it as 2, 0 to root y, the entire PDF. Then this one half 2 cancelled. We had 0 to root y to the power minus of mod x, but writing mod x is equivalent to writing x because the range of x is positive, it starts from 0. So then after integration we'll end up at this expression, and since x belongs to real line, y is x square, y will always be non-negative. So this one is the final answer. Is it okay? Any doubt here? Okay, thank you. Fine. So we'll now proceed with the concepts. I'll just briefly touch up on the concepts which were discussed during this week, and then we'll move on to the problems. Is there anything you wanted to say, Tamanna, Kapil?
No, ma'am.
Okay, okay. There was some noise coming, so I just muted you. I'm sorry for that.
Sorry, ma'am.
Okay, okay. Thank you. All right. So, briefly, the lectures touched upon concepts of moments and inequalities. In terms of moments, Sir talked about expectation, variance, how to find higher order moments, and some moment equalities and generating functions. So, the first order moment that was discussed was expectation. In some scenarios, when you talk about mean of a random variable, what essentially we are referring to is the expectation. Okay. Now, this is the, here goes the definition. If we have a random variable that is defined on the sample space sigma field, and this is the probability measure, then if x is discrete and if expectation exists. Now, how do we test for expectation if it exists? This quantity, summation of xi, probability of x equal to xi, this should be finite for the expectation to exist. If it exists, then only we can write the expectation value as summation of this thing xi, probability of x equal to xi. So expectation will exist only if this expression, that is this series, converges in absolute sense. Mod of xi into probability x equal to xi should be finite, and then only we can write expectation as summation of xi without the mod probability x equal to xi. This is what happens in a discrete case. Similarly, in a continuous setup, we will first check if expectation exists. How we'll check it? We'll integrate with fx dx and add the absolute term mod x. And if this quantity is finite, it exists, then we can compute expectation as, sorry, here there should be no mod. I'm extremely sorry. Expectation will be minus infinity to infinity x fx dx. Alright. Now, there were a few remarks or properties which come handy during problem solving. That is, expectation of any constant, that constant itself. Expectation of ax plus b, where x is the random variable, a and b are constants. So that can be broken down and written as a of expectation of x plus b. Also, probability x greater than equal to 0 is 1. Then it means, what it means is that if there is a non-negative random variable and if the expectation exists, then the expectation of that random variable will also be non-negative. Okay, so this is quite intuitive, because if all values are positive, then the probabilities are also positive or non-negative. Then when we make products, and then that term will also be non-negative. Okay. Also, if we have a random variable and we have some function of that random variable, then if, depending on whether the original random variable is discrete or continuous, we can just write expectation instead of x. Now our quantity of interest is gx. So in previous, wherever we have written x into probability x equal to xi, we'll just substitute that x by gx. in case of discrete, we'll sum it over for n different points, or how many we have. But for continuous variable, we'll just integrate. Okay. Also, somebody said something.
Ma'am,
Yes.
is expectation always positive?
Expectation is not always possible. That is what I'm saying. It will only exist when that modulo thing that I was showing, the absolute value, when these two exist, this one and this one, the ones highlighted over here.
Yes, ma'am. I meant positive. Is it always
Expectation,
positive?
no. It will depend on the random variable.
So if
But
the random variables take both positive and negative values, there is a chance of getting both positive and
yes,
negative.
yes. There is
Yes,
a
ma'am. Thank
chance
you.
of getting both positive and negative. So just as a toy example, if you can see, let's say you have some x equal to -1, -2, 0, 1 and 2, and the probabilities are 0.3, 0.4, 0.2, so this is what, 7, 9, 0.05, 0.05. Okay, these are the probabilities. These add up to 1. So x can take these values with probabilities these. Now if you have to find expectation of x, then that will be -1 into 0.3 plus -2 into 0.4 plus 0 plus 1 into 0.05 plus 2 into 0.05. So then this will be -0.3 minus 0.8 plus 0.05 plus 0.1. So this thing will be negative only.
Okay, ma'am. Thank you,
Okay,
ma'am.
but expectation can be calculated in this way, because if we take the expectation exists, why can we say it? Because if we do this thing, summation, mod x into probability x equal to x, then we have what? Mod of -1, that is into 0.3 plus mod of -2 into 0.4 plus 0 plus 0.05 plus 1, 0.1 something. So this will be 0.3 plus 0.4 something, which will exceed 1, but this will be some finite quantity less than infinity. Okay, so depending on your random variable, expectation can be positive, it can be negative. But if the random variable itself is never negative, then the expectation can never be negative.
Yes, ma'am. Okay,
Okay?
ma'am.
Okay. Thank you for the question. Alright. So, next, what was done, if we have, so we discussed this thing. If x is a continuous random variable, then expectation, if it exists, then this is the formula, irrespective of whether x is positive or negative. But if x is not negative, that is x greater than equal to 0 always, then this part is going to vanish and we are going to get this thing. Okay? Alright. So then the next thing that was discussed was variance. So variance, what essentially, so expectation, what it captures is that it, in some way, it captures the mean or the central tendency of a random variable. And variance, it captures the spread around mean. So whenever variance is there, this is the formula. Variance of x equal to expectation of x minus mean whole square, where mu is the mean. So we are considering how much this random variable is actually deviated, we are quantifying that deviation with expectation x minus mu whole square. Okay, now this, from here we can come here directly by using the properties of expectation. So here we have x square minus 2 mu x plus mu square, something like this. So this can be written as expectation of x square minus 2 mu expectation of x plus mu square. The expectation of x is again mu, so we can write expectation of x square minus 2 mu square plus mu square with expectation of x square minus mu square. So instead of mu, we are writing expectation of x whole square. Okay. Next, the thing is that variance of a is 0 if a is a constant. If we have a constant value, that means it is not varying. The mean is also constant, the same thing. So then variance of any random variable which takes only a constant value is 0. And since this is a squared term, this will always be greater than equal to 0. If you have something, if your output shows variance x or variance is less than 0, then there is some problem. You should be always mindful of this. Variance can never be negative. It can be 0, that would imply that it is a constant, but it can never be negative. Okay. Also, as I was saying, if you have a constant variable, that is probability x equal to a is 1, then also variance will be 0. And this is another property of variance. So variance is, it varies when we have a scale change, but not when we have a shift. So ax plus b will always be a square variance of x, and variance of b is 0, and since it is only 1, there is no covariance involved. So variance of ax plus b will be a square variance of x. If we have x multiplied with some sort of scalar, that scalar will be squared, and then we have to multiply it with the variance of x. But if we have something plus minus, then also variance is not going to change. So instead of ax plus b, if we have variance of x by 4 plus 1, it will be 1 by 16 variance of x. Okay. Then we moved on to some moment inequalities. So this was the Markov's inequality, which states that if I have a non-negative random variable whose expectation exists, then for any given t which is positive, this equation will hold. Probability x greater than equal to t will be less than expectation of x by t. Okay, this proof was there in the lecture. And the Chebyshev's inequality states that x is a random variable where both expectation and variance exists, then probability mod of x minus c is greater than equal to epsilon for any given epsilon greater than 0 will be less than equal to expectation of x minus c whole square by epsilon square. And as a special case, if c equal to mu, then we would have probability x minus mu greater than equal to epsilon will be less than equal to sigma square by epsilon square. How sigma square? Because if we replace c by mu, then this is the by definition the variance, and we know we have assumed variance to be sigma square over here, which is known. Okay, so this is the Chebyshev's inequality. We also discussed two more inequalities. One was the Jensen's inequality, which stated that if x is a random variable where expectation x exists and g is a convex function, then expectation of gx will be greater than equal to g of expectation of x. So a convex function usually means if you difference it, I mean second order, if you do differentiation, then that should be greater than 0, if I'm not wrong. It should be non-negative. Second order difference, this should be non-negative. There are other formulas also, you can check it out. Okay, so if it is a convex function, then expectation of gx will be greater than equal to g of expectation of x. And we also have Lyapunov's inequality, which states that if bn, that is expectation mod x to the power n, if it exists, then for any k we would have 1 by b, this one where we'll just have beta k minus 1 to the power 1 by k minus 1 will be less than equal to beta 1 by k, beta k to the power 1 by k. Okay, an inequality will hold if and only if probability x equal to some alpha constant is 1. That is, equality will only hold when x is a constant. Alright, so after this we went ahead and studied about probability generating function. So in order to study about PGF, the assumption was that x is a non-negative integer valued random variable. That is, x can take values from 1, 2, 3, 4, so on. Non-negative and integer. Then probability k, pk, probability x equal to k, if we define it in this manner, then the probability generating function can be written in this manner. Summation k equal to 0 to infinity, probability x equal to k, s to the power k, where we should be mindful that s has to be less than or equal to 1, because only then this series is going to converge. This function will be defined or it will exist. So this thing, gxx should be 1, gxs. So if I just look at it in this manner, this is nothing but expectation of s to the power k. Whatever expectation we have, we wrote that term multiplied by the probability x equal to k, and then we are summing it over all k's. So gxx s is essentially equal to expectation of s to the power k. And also, if we have something like this, then gx1 can be defined as the factorial moments. Okay, and also pk, probability x equal to k, can be written as 1 by k factorial. We differentiate up to kth order. After differentiating, we substitute the value of s equal to 0. That is going to give me my pk. Okay, and these are unique if for two distributions, if we have the same gxs for all s, then we can say that the two distributions are the same. X and y have the same distribution. Then we moved on to the definition of a moment generating function. Here the added, so the previous assumption was that it had to be a non-negative integer valued random variable. Here we have no such criteria. Here the criteria is it can be any random variable, discrete or continuous, but this expectation of e to the power tx should exist for some t in some interval including 0. So then the formula for MGF is this thing. MXT is expectation of e to the power tx. So it will be 1 plus t by 1 factorial expectation of x, t square by 2 factorial expectation of x square, and so on, t to the power n by n factorial e to the power x to the power n. Okay. And expectation, if we have to find out, then so from this here you can see, if you differentiate up to nth order successively and then put t equal to 0, then we are going to get this coefficient. Sorry, then we are going to get expectation of x to the power n. Until and unless we differentiate this n times, this value and set it to 0, this value will not go away, will not get this term. Okay. So in order to find expectation of x to the power n, what we have to do is that we have to keep on differentiating up to nth order the MGF. After we have finished our differentiation, then we have to substitute t with 0, and whatever we get, that is expectation of x to the power n. Here also, if two MGFs are the same, then x and y have the same distribution. And another thing is that the characteristic function, it can be defined for all random variable. We need not worry whether expectation exists or not, because expectation will always exist. So x, a characteristic function, can be defined for any random variable. MGF can be defined only when the expectation this exists. Okay. So instead, what is the difference between MGF and characteristic function? So here we have e to the power tx. Here instead of e to the power tx, we have the e to the power itx. I is nothing but square root of minus 1. And from here, from the characteristic function, if we have to find out the expectation of x to the power n, then we have to do the same thing. We have to differentiate up to nth order, then find the value at t equal to 0, and we have to add this 1 by I to the power n term. I mean, not add, we have to multiply it with 1 by 1 I to the power n, and then we'll land up at expectation of x to the power n. Okay, and these were the properties. Psi of x at 0 is 1, and absolute psi x t is less than equal to 1 for all t. Here again, if both have the same distribution, if the characteristic functions are same, then x and y have the same distribution. Okay. Any doubt till now? All right. So now I'll move on to the question. So here we have a continuous random variable, and this is our PTF. X square 2x plus 3 by 2. Now we have been given that y equal to 2 by x plus 3. So what we have to do is finding the variance of y. So we'll start variance of y can be written as variance of 2 by x plus 3. Okay, this thing can be written as, so this is variance of ax plus b. So this has to be a square variance of x. Using this, we'll only have this to be variance of, a square, here a is 2 square variance of 1 by x. Okay, so that will be 4 variance of 1 by x. Now we are going to use the formula for variance. Variance of x means expectation of x minus mu square, or in other words we can write expectation of x square minus of expectation of x whole square. Okay, so here we are going to apply the second formula. So this one we'll write as 4 into expectation of, this will be my x, gx something. Okay, so variance of, here let's say gx equal to 1 by x. So variance of gx will be expectation of gx square minus expectation of gx whole square. So here we'll write it as expectation of 1 by x square minus expectation of 1 by x whole square. So we have written it down, we have broken it up, expectation of 1 by x square minus expectation of 1 by x whole square. Now what we'll do, we'll find out each of the individual terms. So here we have our PDF as this. So the fx is x square 2x plus 3 by 2, 0 if 0 less than equal to x less than 1. Sorry, this is not defined at 0. Okay, 0 less than x less than equal to 1 and 0 otherwise. This function is defined at 0, but I was talking about 1 by x. So if I put so this, why I could not come, I mean this mistake is not possible because here 1 by x, if x is 0, this will not be defined only. If x equal to 0, we have something. If it is possible, if it has greater probability, some probability. Okay, so that is why it was incorrect to put less than equal to over there. All right, so here we have this PDF. We have to find out expectation of 1 by x square, and x is a continuous variable. So what we'll do, we'll just write down minus infinity to infinity, let's say 1 by x square, I mean I shouldn't be writing this, but this should be 1 by x square fx dx. Okay, so this, everywhere else it is 0, fx is 0, but only from 0 to 1 fx is defined. So then we can write this as 0 to 1, 1 by x square into x square 2x plus 3 by 2. X square will cancel out and dx of course. So here we would have 2x square by 2 plus 3x by 2, 0 to 1. Substituting 1, this 2 will cancel. We will have 1 plus 3 by 2 minus 0. That is 5 by 2. Okay. So we have this. Next I have to find out expectation of, in a similar process, expectation of 1 by x. So that will also be 0 to 1, 1 by x into PDF, x square. What was the PDF? 2x plus 3 by 2. So x and one of the x's cancel. So we have 0 to 1, 2x square plus 3x by 2 dx. This will be 2x cube by 3 plus 3x square by 6. 3x square by 4. 0 to 1. So this will be 2 by 3 plus 3 by 4. 12, 4 2s are 8, and this will be 9. That is 17 by 12. Okay. Now we wanted these two values. We have that. So now then variance of y would be 4 into 5 by 2 minus 17 by 12 whole square. So this will be 4 into 5 by 2 minus 189 by 144 to 4. 72 into 5 will be 360 minus 189. So this will be 1 7 this will be 289. Extremely sorry. 71 by this 4 and 144 will cancel. 4 3s are 12 and 4 6 are. So this is the final answer. Is it okay? Any doubt? Alright, so if not, then I'm going to proceed to the next one. Okay, so here this says that x is a discrete random variable with PMF this. We have to find the MGF. So MGF can be written as mxt equal to expectation of e to the power tx. So then that can be written as e to the power t into 1, probability 1/3, plus e to the power t 2, probability is 2/3. So we can write it as e to the power by 3 plus 2 e to the power t by 3 can be written as e to the power 3. Sorry, to the power, we cannot write this. Sorry, this will be 2t. 2 e to the power 2t. So then e to the power 3 we take common, it will be 1 plus 2 e to the power t. Okay. Alright. So here we have a random variable with moment generating function this. Then we have to find out the variance of x. So how variance of x would be expectation of x square minus expectation of x whole square. Now we know expectation of n x to the power n will be d dt n times we are doing of the MGF, and then that is evaluated at t equal to 0. So expectation of x will be expectation of x will be d dt of half 1 plus e to the power t evaluated at t equal to 0. That is half it will not come. So 1 by 2 e to the power t evaluated at t equal to 0. T equal to 0, this is 1, so expectation is half. Okay. Now next what we have to do? We have to do expectation of x square. This is d2 dt square half 1 plus e to the power t evaluated at t equal to 0. Which is, so expectation x we got this one, half e to the power t. So this will be again d dt of half e to the power t evaluated at t equal to 0. So that will be again half e to the power t at t equal to 0. This will be again half. So then variance of x is what? Expectation of x square, this one, that is half, minus expectation of x whole square, that is this half whole square. It is half minus 1 by 4, this is 1 by 4. Is it okay? Any doubt?
No, ma'am. Yeah, that.
Okay. Alright. So we'll move on to the next one. So let x be a random variable with which is following a normal 0 sigma square. Then the moment generating function for the random variable is given by what? So can you try this out? Do you know the PDF of normal random variable?
Yes, ma'am.
Okay. For those of you who are not aware, fx let if x follows a normal mu sigma square, then fx would be 1 by root 2 pi sigma e to the power minus half x minus mu by sigma whole square. So here we have been given that x follows normal 0 sigma square. So then fx would be 1 by root 2 pi sigma e to the power minus half x square by sigma square, and the range is minus, x can range from minus infinity to infinity. So the MGF will be expectation of e to the power tx. So this will be integration over minus infinity to infinity 1 by root 2 pi sigma e to the power tx into e to the power minus half x square by sigma square dx. Can you please try and proceed? Here, how should you do it? So first thing is we have to club these two together. So I'll write it in a fresh page. MGF is expectation of to the power tx. That we are writing as minus infinity to infinity e to the power tx by root pi sigma into e to the power minus half x square by sigma square dx. So this we can write as minus infinity to infinity e to the power tx minus half x square by sigma square dx. Now let us assume y equal to x by sigma. Then dy would be dx by sigma. Okay, so this we can write as minus infinity to infinity 1 by root 2 pi e to the power sigma ty minus half y square dy. Okay, now if we take minus half common, this can be written as y square minus 2 sigma ty dy. Okay, so here we are saying something very similar to a minus b whole square. Okay, so if I have to write it, so this is y square minus 2 sigma ty something. Okay, All right. So this, if we have to write in terms of some a plus b whole square, sorry, a minus b whole square, we have to add some terms to it, and then to adjust we have to take out some other terms. So this thing, so we had this one, minus infinity to infinity 1 by root 2 pi. Just give me a second. Hello? Hello? Yes, sir. हाँ, please keep it in the reception. Thank you. आप जिंदल में दे दीजिए, फिर कोई होगा वहाँ पे. ओके, BPCL में आप दे दीजिए, वो बोल दीजिए BPCL का है. ओके, थैंक यू. Really sorry. So where was I? हाँ. Here. Am I audible now?
Yes, ma'am.
Yeah, okay. Sorry about that disturbance. Okay, so we had this minus infinity to infinity 1 by root 2 pi e to the power minus half y square minus 2 sigma t y. So if we write plus sigma square t square and then again minus sigma square t square dy, we can do it, no problem. This we can write as minus infinity to infinity 1 by root 2 pi e to the power minus half y minus sigma t whole square into e to the power sigma square t square by 2. Okay, dy. Now this term doesn't involve y, so we can take it out, e to the power half sigma square t square, and we are left with minus infinity to infinity 1 by root 2 pi e to the power minus half y minus sigma t whole square dy. So if we look carefully, if I forcibly write here 1 and divide by 1, then does this look familiar? Any resemblance you can find? Okay.
This is the PDF
Yes.
with sigma 1, not by 1.
Exactly. So this is minus infinity to infinity some gx dx, where, or let's say gz dz, where z follows a normal sigma t 1. Okay, so now we are integrating the PDF, raw PDF, over minus infinity to infinity. Then what should this value be?
It should be 1.
It should be 1, exactly. So then we have this entire region. This is nothing but minus infinity to infinity gz dz, which is 1. So ultimately we have half sigma square t square. This is our answer. Is it okay?
Yes, ma'am.
Yeah. All right. So then this is done. Next one. So how can we proceed with this one? Any idea? All right. So we have the moment generating function of a random variable given by these 4 terms. Now MGF is nothing but expectation of e to the power tx. Okay, so when x is 0, we would have, so the first things first, we'll see if these 4 numbers, how much they add up to. Okay, so 1/6 plus 1/4 plus 1/3 plus 1/4, this will be half, plus 1/6 plus 1/3 is also half. So they add up to 1. These two 1, half, these two half. Alright, so this, in some way, we can write the values that x is taking and the corresponding probabilities. So from here, let's say this is x and this is my probability. So x when 0, e to the power 0 is 1, and we have probability x equal to 0, that is 1/6. When x is 1, e to the power 1t, probability is 1/4. Okay, when x is 2, probability is 1/3, and when x is 3, probability is 1/4. Okay, so then what will be the mean and what will be the sigma value? If you calculate, can you please calculate?
Is it 5/3 then?
5/3. So expectation, how did you calculate?
All the x values into their respective probability values, we'll have to add.
Okay, so 0 into 1/6 plus 1 into 1/4 plus 2 into 1/3 plus 3 into 1/4. So this is 1/4 plus 2/3 plus 3/4, 1 plus 2/3, that is 5/3. Okay, so sigma, similarly,
Is it 13 by 6, ma'am?
Is it 13? I'm getting 7 by 3. Is there any mistake I did in my calculation? Can you check?
No, that's fine.
Okay, so this is expectation of x square that I have calculated. So you are talking about sigma, right?
Yes, ma'am.
Alright, so sigma square is 7 by 3 minus 25 by 9. I think I've
Oh,
made
yes,
some.
ma'am. My mistake, ma'am. I forgot to square the expectation of x term.
Okay, okay. So, but then this is also coming negative, so I must have made some mistake. Can you please check where I went wrong? Oh, here. This is 10 by 4. Sorry, this shouldn't be. Uh, 10 by 4 means 5 by 2. Here I've made a mistake. Six, 15 plus 8, 23 something. So
Ma'am, sigma square is 22 by 9.
32 by 9.
22 by 9.
Sigma square is 22 by 9.
Yes.
Okay, I'll just check. This one 18. So 3 is at 9. 369 minus 50. I'm getting 19 by 18 something. Is this correct? This part?
Oh, yes, ma'am. I forgot to multiply it by 2, ma'am. Yes, ma'am. 69 minus 50 by 18 is correct, ma'am. So it's 19 by 18.
It's coming 19 by 18. Okay.
Yes, ma'am.
19 by 18. So then this will be something close to 1 point something something. Alright, and our mu is also close to how much? 1 point. It's exceeding 1. Okay, so this one we have to find out now. Probability mu minus sigma less than x less than mu. So how much is this coming? 19 by 18 square root. .005. If we have to do a square root of 19 by 18, it's 1.027 something. So mu is 5 by 3. So if we do 5 divided by 3 minus square root of 19 divided by 18, this quantity is probability 0.639 something. Less than x less than mu. Mu is 5 by 3, that is 1.667. Okay, so this is the value that we want. Now x is a discrete random variable, so between 0.639 and 1.667, what value of x do we have? X equal to 1.
1.
So that is 1/4. So the final answer is, so I'll write it a little clearly so that the slides are proper. So from here, 1 second. So that is the answer. 1 probability x equal to 1. Okay, this is mu. 1 second. Mu. So here,
Ma'am, can you
yes,
please tell why we are taking x is equal to 1?
yes,
didn't
I'll
get-
tell. I'll tell. So mu. So here we have mu equal to 5 by 3. That is 1.667 something. Okay. And sigma we had root over 19 by 8, which was 1.05 something root. This is also close to some value. If you find out root over 19 by 16, how much do you get? Just calculate. Root over 19 by 18 is 0.707. Okay. So mu minus sigma is coming close to so if you do this 5 by 3 5 divided by 3 minus square root of 19 by 18, this is coming close to 0.639. Okay, so we have mu sigma and mu minus sigma values over here. Now we want to find out probability 0.639 less than x less than 1.667. Okay, now x we have to see here x is taking discrete values with certain probabilities. So it can take value 0, next value it can take is 1, the next value it can take is 2, nothing between 0 and 1. So here we are saying that x is greater than 0.6 but it is less than 1.667. So the only value that x can cross, x can attain within this range is 1. If it is 0, then it can't be, this condition is violated. If it is 2, then this condition is valid. Only when x equal to 1, both the conditions hold true. Do you get my point?
Okay.
So that is why we put probability x equal to 1, and that is from the table 1/4 or 0.25. This is my answer. I don't think you are convinced. Okay, can you repeat where you are facing problem?
No, I can understand. I just couldn't understand why the discrete value. Now you told, and that I can understand right now.
Okay, so because it is discrete and it's taking only these 4 values, that's why it can only take 1 in this range.
Okay.
Alright, thank you.
But the mu minus sigma is the 0.69, 1.667 minus 0.707 is something.
You
Mu
can
minus sigma value, mu is equal to 1.667 and sigma is 0.707. So when we subtract 0.639 is the answer, I doubt.
It could be something, if looking at these figures, it could be a little more. Okay, so it
Got
will be 0.9 something from these figures. So these are rounded up to 3 decimal places. When I do it in the calculator, I'm getting this. But something similar you are going to get, okay? So
Can we take calculator during the exam time or?
I don't think so. But
Okay.
you can ask the NPTEL team.
Mm-hmm,
Alright.
mm-hmm. Finding out the square root and things like
Yeah,
that seems
these
to be very difficult.
require calculator. I am not so sure about the protocols of the examination. Please confirm it with the NPTEL team.
Got it, ma'am. Thank you.
Okay, okay. Sorry, I couldn't answer that. I really don't know. Okay. So, shall I proceed to the next one? All right. Here we have another problem. So, suppose x is a continuous random variable having the following PDF. So, then y equal to modulus of x, then expectation y will be given by what? So, as usual, we'll proceed from the definition. Alright, so here x is a continuous random variable having this PDF, y is modulo x, then expectation of x is given by what? So here also we have expectation of some gx, where gx equal to mod x. Okay, so then we can write it as minus infinity to infinity gx into fx dx. Now here the entire range of x has been broken up into two parts, less than 0 and greater than 0. So we can also similarly break this entire thing into two parts. So we'll have minus infinity to 0 gx fx dx plus 0 to infinity gx fx dx. Is it okay? Now, when x takes a value from minus infinity to 0, that is here, then fx is e to the power x by 2. So here we'll write fx as minus infinity to 0 mod x e to the power x by 2 dx plus 0 to infinity mod x into e to the power minus x by 2. Okay, dx. Now first we'll take the positive side and then try to find out 0 to infinity. This one we are going to take mod x e to the power minus x by 2 dx. We can write it as 0 to infinity x e to the power minus x by 2 dx. This we can write as half 0 to infinity x e to the power minus x dx. Then we'll do integration by parts. So how can we do it? Half x integration e to the power minus x dx minus d dx of x into e to the power minus x dx is total to 0 to infinity. So this we can write as half x e to the power minus x by minus 1 minus, so this minus will come out, d dx is 1, so we'll have plus e to the power minus x dx 0 to infinity. So this will be half minus x e to the power minus x minus e to the power minus x 0 to infinity. Substituting the value of infinity over here, this will go to 0, this will go to 0. So first thing is 0, half 0 minus this entire term will be 0 because x is 0 minus of e to the power 0 is 1. So we have half. So this part is sorted. This one we have half. Now we'll get to the next part. So here what we had, when we had minus infinity to 0, mod x e to the power x by 2. Okay, so here we can write it. So mod x is x when x greater than 0 and minus x when x less than 0. So in this range x is less than 0, so we can write it as minus infinity to 0 minus x e to the power x by 2 dx. So we'll take minus over here, minus infinity to 0 minus half x e to the power x dx. Again we'll do integration by parts. This we'll write as minus half x integration e to the power x dx minus d dx of e to the power x, sorry, d dx of x integration e to the power x dx minus infinity to 0. So this will be minus half x e to the power x minus of e to the power x minus infinity to 0. So this will be minus half 0 minus 1 minus, when we put minus infinity, if we substitute over here, both of these will tend to 0. So we have half. Thus again if I have to come back here, so this thing is half, this thing is also half, so we have 1 is the answer. Is it okay? Is it okay?
Can you, I was not in the previous class, could you please help me understand how to do the integration by parts if that allows you?
Okay, so have you taken mathematics in your plus 2, 11, 12?
Yeah,
Okay,
yes.
so you must have heard of I forgot, there's one Eilert rule. So this is for logarithmic, this is for trigonometric, this is for exponential function. This is I think algebraic, and this one I forgot. So what is it? If you have some, let's say, function, let's say you have fx and some gx. you have to follow this order in order to integrate by parts. So what is it? If let's say this is a logarithmic function and let's say this is an exponential function, or let's say this is whatever we have. Let our this be some algebraic function x, and let this be some function involving the exponential terms. So in order to, if you have something like fx dx gx based on the order, let's say this is my first one and let's say this occurs, I mean this is in the beginning and this is in the end. So what we usually do is that first we keep fx as it is, integrate in terms of the second order function, minus within the integration we first differentiate the first function and then we integrate the second function dx, and this entire thing we again integrate. Okay, so here we had x, some terms involving, so here we had some terms involving x and some term involving the exponent. So our first function in this case fx was x and gx was, depending on the case, e to the power minus x or e to the power x. So first we took the function as it is, integrated in terms of e to the power x dx, minus within integration first we differentiated the function x and then again integrated the exponential function, then that entire thing whatever we got, that we again integrated. So here you see this one was my fx and this one was my gx. So first we kept fx, integration, this was integration gx dx, minus this was d dx of fx, again integration of gx dx, and then again dx. So here
Okay. Got it. Thank you.
So here
Thanks a lot.
okay, I think you got it. So here once we got e to the power x, again we integrated, that also is e to the power x because there is no sign change. But here there was a problem. The sign change, it reversed. So here we had e to the power minus x minus 1. So that minus minus became plus over here. It's okay, right? Okay, thank you. Fine. Okay, let us try this out. So here we have x as a continuous random variable and they've given that the probability density is this. Then how can we find out expectation of x? Now here k is unknown. So how will we find out k? They have given that this is a probability density function. So integration of fx dx should be 1. So x can take value, I mean this density is something when x is greater than 1 and it is 0 otherwise. If nothing is mentioned, just understand that it is 0 otherwise. So then it means integration 1 to infinity k x square e to the power minus minus x plus 1, like that they have said, minus x plus 1 equal to 1. Okay, so here we can write it as 1 to infinity kx square e to the power minus x into e equals to 1. So ke we can take out. Oh, or I think this is okay. So let's do something. Okay, so here we can write this as 1 to infinity k x square e to the power minus x minus 1 dx equal to 1. Let us write y equal to x minus 1, then dy equal to dx. Substituting here, our lower bound will become now 0 to infinity k y minus 1 whole square e to the power minus y dy. That should be equal to 1. So then here this will be k 0 to infinity y minus 1 whole square e to the power minus y dy equal to 1. K 0 to infinity y square to the power minus y minus 2y to the power minus y plus e to the power minus y dy equal to 1. Okay, now we'll do this thing by parts. So 0 to infinity y square e to the power minus y dy, it will be y square integration to the power minus y dy minus d dy of y square integration of e to the power minus y dy whole thing dy. Okay, so then this will become y square e to the power minus y square minus e to the power minus y minus 2y minus of e to the power minus y dy. That is this entire thing within 0 to infinity. So we'll have minus y square to the power minus y from 0 to infinity plus integration 0 to infinity 2y e to the power minus y dy. Okay, so then if yes,
Can you please go to the question slide, ma'am? So why can't we use integrating by parts in the first step itself, ma'am? And that's x square e power minus.
we can do it. We just have to be mindful of this I thought because this is 1 and to infinity, if I do minus 1, then it will become easier for me. You can of course go ahead here. Yeah, you can go ahead here. So do something. You go from here and I'm going this way. We'll see if we land up at the same point.
Yeah, okay.
Okay. All right. So 0 to infinity this thing. If we just do minus of this 0 to infinity 2y e to the power minus y dy, then this part essentially is 0. Do you get my point? So here this y integration of 0 to infinity y square e to the power minus y minus integration 0 to infinity 2y e to the power minus y, if we do, then this part is becoming 0. So from here again, what we have is k 0 to infinity e to the power minus y dy equals to 1. So it is k e to the power minus y by minus 1, 0 to infinity. So this is 0 minus minus 1 equal to 1. That means k equal to 1. I am getting k to be 1. How much are you getting?
I'm kind of stuck in that step only. I
Okay.
can do it now.
No, you'll be able to do it. Why? We'll see. We'll do it again. Let's say we have, what was it? We had 1 to infinity kx square e to the power minus x plus 1. This is what we had, no? Okay. So we'll take out ke. Okay. 1 to infinity x square e to the power minus x dx. So then we had ke. Same thing. X square integration e to the power minus x minus d dx of x square e to the power minus x dx, again dx. Ke x square minus e to the power minus x minus 2x, so plus 2x e to the power minus x dx. Okay. So then again this part you have to do the by parts again. Okay. So here, so this will be 1 to infinity. So if we put the values over here, 1 to infinity, this one is 0 and 1 is ke into 1. So that is, this is 0 minus of, if we put 1 into e to the power minus 1. Minus of minus. So here also we will land up at k only. This will be k. Plus we will have something. That too 1, 2. So here also we will have k plus. Okay. So here we will have k plus, again 1 to infinity 2x e to the power minus x dx. So again we have to do k plus 1 to infinity, we have 2 over here, sorry, this one will be x integration to the power minus x minus d dx of x into e to the power minus x dx, again dx, 1 to infinity. This will be k plus 2 x e to the power minus x minus e to the power minus x dx, 1 to infinity. Into k plus 2, this will be 0 minus this will be minus 1 by e plus 1 by e. So this will be again 0. 0 minus 0, this will all again be only k. So the entire thing then again boils down to k equal to 1.
Thank you.
Okay. So both ways it is possible. So now the first step is done. Okay. So we have figured out k is 1. We know. Alright. 1 second. So now when we have figured this out, we know that k equal to 1. So then again, if now the job is to find out expectation of x. So expectation of x will be same thing, 1 to infinity. K is 1. We need not worry about k. So we'll have x into x square x into x square. What was that? E to the power minus x plus 1. E to the power minus x plus 1 dx. Okay. So here again I'll write it like this, 1 to infinity x cube e to the power minus x minus 1 dx. Again I'll write y equal to x minus 1, dy equal to dx. So this will become 0 to infinity y minus, sorry, this will be x cube, no. So it will be y plus 1 whole cube e to the power minus y dy. Okay. But then I think I made some mistake here. Y equal, oh, this should have been x plus 1. Kx square, it should have been x plus 1 square. Okay, then x plus 1 would have become something like this. Then y square minus 2y to the power minus y would have been plus 2y e to the power minus y. Okay, some problem is here. This one I did not notice. Okay, but the main point is that we have to first find out k, and then after k is sorted out, maybe it will come 1 only, because the other method also we tried, it came out to be 1. So then we have to find out how to proceed with the expectation thingy. Okay, so then here again we have to break it up. A cube plus b cube, y cube plus 3y square plus 3y plus 1 e to the power minus y dy, and then whatever we get the value, that is the answer. Is it okay? So here there is some problem in sign. So this one I took y equal to x minus 1 as my y. So x I should have written x y plus 1. So then y plus 1 whole square to the power minus y. This should have been this. This is y square minus e to the power minus y minus 2y integration of e to the power minus y, that is plus integration 0 to infinity 2y to the power minus y dy, and this thing is 0. So then we would have landed up at 4y e to the power minus y. So if I have to correct this one, this was also plus, right? So from here we have k 0 to infinity 4y e to the power minus y plus e to the power minus y dy. So then if we do integration y from here, if we do so integration 4y to the power minus y dy, this will be 4 into y to the power minus y dy minus of 1 into e to the power minus y dy, again dy. So that will be 4 y to the power minus y minus of e to the power minus y dy. It will be 4 minus y to the power minus y plus e to the power minus y dy. Sorry, plus integration 0 to infinity e to the power minus y dy. 4 something. Sorry. This will be plus e to the power minus y, be 4 y to the power minus y minus y to the power minus e to the power minus y 0 to infinity. So this will be 4 into 0 minus 1. So this part will come as 4. Alright. So then we'll have some value of k here. Okay. So this thing came around to be, this thing is 4. So we have 4k, 4 into, oh no, we have what? 4k into 4 plus integration to 0 to infinity e to the power minus y dy. So we'll have 4k plus k e to the power minus y 0 to infinity. This is 4k plus k, 0 minus of minus 1. So we have 5k. So from here we have k equal to 1 by 5. Okay. K is not equal to 1. K is equal to 1 by 5. So we have to check. K is equal to 1 or 1 by 5. I think this is the correct thing. So once we have this, then in order to find out the expectation, we just have to replace, instead of k here, we have to give 1 by 5 and then proceed accordingly to get the answer. Okay. You understood how to do this thing. This will be a little more rigorous. Like y cube e to the power minus y, we'll have a y square term, then y square term will have also a y term, and then we'll land up at this thing. But we have to follow that integration by parts rule. Any doubt, confusion? In the methods at least? Okay, so I think I hope.
Ma'am, the one that you said integrating by parts, so that you gave a clue, I late, something like that. So it's there are two functions, f of x and g of x, and f of x is a logarithmic function and g of x is an algebraic function. So we take logarithmic one first and the algebraic one next.
Yes, I think that is the rule. Integration by parts has a specific order. I'll just confirm it. Yeah, so mostly what I learned is the Eilert rule. Yes. Eilert rule is inverse. Yeah. So for integration by parts, we have to follow the Eilert rule. This is for inverse. This is algebraic. This is trigonometric. This is exponential. And this is logarithmic. Okay. So if I have to find out u v dx, ux vx dx, this, let's say 1 2 3 4 5, something like this. So then first function should be somewhere here and the second function should be closer to this thing, and that is ux integration vx dx minus d dx of ux integration of vx dx total dx.
Okay, ma'am. Thank you, ma'am.
Okay, so then you just have to follow this path and keep on doing the calculation to land up at this thing. Okay, so I think we have come close to our stopping time. So from today's session, is there anything where you got stuck, you couldn't understand but you want me to repeat? Please feel free to ask. Any problem where you think you need some more explanation from whatever I discussed today?
Can we see the PPT or something to refer?
I'll be uploading these PPT and the NPTEL team will make this available to you. So you please, if you're not yet getting it, please write to the NPTEL team. I think they'll share it on the web portal where you can access it. So last time they did that.
Okay.
If you go to the course homepage, I think you will find some doubt clearing or problem solving session link. I don't know whether it's active yet or not, but it's supposed to be there. Okay, so if you do not get it, please write to the NPTEL team. I'm sure they are going to share this with you. Okay, so if not anything else, I'll be signing off today. Thank you so much for joining, and hopefully I'll see you in the next class. Meanwhile, if you do have any problem in understanding whatever I discussed today or any other general thing, you can use the discussion forum. You can also ask me during the next session. Okay?
Yes, ma'am.
Okay. Thank you so much, ma'am, for joining. Have a nice day.
Thank you,
Bye
ma'am.
bye.
Thank you, ma'am.
Thank you, ma'am.